Welcome to this new series that I've prepared for you. As I promised, I will start giving back to the community, and the topic of my choice, a bit controversial, I must say, but it's a really good topic that I think every software engineer out there should be familiar with, is unit testing or testing in general. So what I will try to put up in this series is the best practices, the core principles, and the patterns that need to be used in order to write good unit tests and learn how to differentiate between bad tests and the valuable tests that you need to have in your code base. So, as you know, I'm Adrian. I am a software engineer, and in this journey, I will show examples used in Spring Boot and Java. So we'll be using JUnit 5 most probably. So stay tuned and yeah, let's get started. For the first starting point, I would say we need to understand the big picture behind what all unit testing, integration testing, everything is. So you may know there are people out there that may say, well, yeah, I don't want to write tests because I want my development cycle to be faster. I want to go into production faster, etc., etc. But let's discuss what is the real purpose of writing the unit tests. So as you may know, one project will not be there just for a couple of weeks. There are products out there that have legacy code for 20 years or so. So as time passes, we know that our code will get more and more complex. There will be new requirements from the client. You will have to change the code and stuff like that. And the end result is it will get buggy. The unit tests are there to help us find these bugs as quickly as possible. So when you write new code and you write, let's say, a buggy code, the unit tests and other types of tests will fail. So you will be able to catch this bug before it goes into production and crashes into the client's code. So basically, they will allow a sustainable growth of the software project. So as the software gets bigger and bigger, with more and more unit tests, this gives us more confidence that our code will do its job as it's supposed to be. And as I said, there will be developers out there that say, no, we don't want to write tests because we want to build features as fast as possible. But I am with the category of devs that say we should always write tests. And I have a good argument to that. Why should we always write tests? Because everyone makes mistakes, right? If someone will tell you otherwise, unfortunately, they lied. And the most important part is that we want our code to work properly now and in the future. So I don't want one part of my code to work now, but after some weeks, when another developer touches something else, the code will break. But it does. So tests are there to ensure that if something breaks, you catch it, you fix it, and you move on. But there are different types of tests, right? They can be good and bad tests. So we need to know why we need to write only good tests. Because it is really important to have only good tests in your test suite. Because I see it this way. You can write tests, but if they're not good, the design of the code, like the whole architecture, may not be right. So there's this thing. If you cannot test the code, it is a really good indicator that the quality of the code is poor. What I mean with this is that if you have, let's say, a code and you decide to write a test for it, if you have to do a lot of workarounds, you have to find other ways to just make the test pass, but without touching the code, then I think it really it tells you something. It tells you that, hey, with your code design, there's something wrong. But the other way around, if you are able to test the code, which I just made an example of, it doesn't mean that your code is good. So you will have the test, you will have the code, but they both will be bad. So I think we should always aim to write good tests and to implement the patterns and the principles of good tests, which we will see in the future videos. So I will make sure to also help you in that regard. Another thing is that many companies have as policies, and devs are forced to match that, is the code coverage metrics, right? There will be companies that will force developers to have 100% code coverage, but I think that is not really ideal. And because if you have a goal to have 100% code coverage, there will be new problems arising. I'll just share a quick story later on. So let's go over it. If the code coverage of the code base is below 50%, let's say, so you have a project and you see there are no tests at all. So this is a really good indicator that there's a problem, right? Because there should be tests. But if you see a code base that has 100% code coverage, still you cannot rely on just that metric that the whole code will work properly. And why? I'll just show you right now. I was reading one book that explained testing and stuff like that, and the author shared a story there where he worked on a project and the company tried to enforce 100% code coverage. And what the devs did, because with every pull request, they had to write tests for the new code. And they found out that if you wrap the test code with try and catch, it will always pass. So what they were doing is wrapping everything. So these are the bad tests that I'm talking about. So you should never do that. And the company then saw that even though there are tests, there are bugs. So they started lowering the metrics, and in the end, they just removed it altogether. So our goal is to write good tests rather than just match a metric, which sometimes it's nonsense. So let's differentiate, because there are different types of code coverage metrics. There is code coverage, which is the lines of code, basically, and then there is this branch coverage. So the code coverage is the most used coverage metric out there, and it's also known as test coverage, and basically is the ratio between lines of code that are executed and the total number of lines. And the other category is the branch coverage, which will provide better insight into the completeness of the test suite, because instead of just using the raw number of code lines, this will focus on the control structures of the branches that a code can traverse to. So basically is the ratio between the number of code branches exercised and the total number of branches in the code base. So, okay, we talked about the good test, we talked about code coverage, but what is that makes a successful test suite, right? You have a lot of tests, but what is it successful? We don't know about that. Number one is that the test suite is integrated into the development cycle. And what I mean by this is you need to be able to run the test with every new change that you make in the code base. So let's make an example out of it. You have a new feature and you code it and you write a test, right? So what needs to be done is you run all the unit tests and see that everything passes before you submit a pull request, right? This is the development cycle. And it is important that every developer can run the tests in their local machine. The second one is that a test suite targets only the most important parts of the code base. So this means that not all the tests are created equally, not all parts of a code base are worth the same. And what I mean by this is there are parts of the code base that you have from a third party, or there will be like trivial parts where you really don't need to test. So one-liners, or we will tackle these in the future. I will show examples of everything, but just have this in mind that not all parts of the code base are worth the same. And one example is the domain model, the business logic, everything that comes as a requirement from the client, that is critical and that needs to be tested, right? So have this in mind for the future series. And number 3 is that it provides maximum value with minimum maintenance costs. So if you write good tests, it means you will not have to maintain them with every change you make in the future. A good test will stay the same even though you change the code or you refactor the code that test is testing, right? So it's not enough to just include tests into a build system. They should be well written, they should be understandable, clean, and with every new developer that comes and looks at that test, it should be readable. So what these two last lines are really important, because every developer should recognize a valuable test and they should be able to write a valuable test. A valuable test is what will give us the confidence that our code will work and behave properly. So this first video, I don't want to give too much practical examples. I want it to be just like a presentation, but in the next part I will make sure to have also code examples with JUnit, and yeah, everyone who is interested in Java will love them. But just may have this in mind, it doesn't matter if you come from another language. The let's call XUnit frameworks all work very similarly, and it will be understood for every engineer out there. So what you can expect from this series? By the end, you will be able to understand the principles, know the best practices and different styles of unit testing. We will tackle on how to refactor the test suite along with the code it covers, because this is a really important part. You will see in the next videos that tests that are able to resist refactoring without changing the test are really valuable tests, and we will be able to identify and avoid anti-patterns in unit tests. So I think ahead you can expect some really good content from my side. I'll make sure it's a valuable content, and yeah, I really appreciate you watching it until here. So please subscribe and hit the notification bell icon for future videos. You will know before everyone. And yeah, have a great day and see you in the next one. Bye bye.